Hi, good evening, everyone. So we are revising exercise 8.4 and the related problems from the miscellaneous exercise 5.4. Okay, so there are three categories of formulae. Okay, first of all, application of the wrong formula will give you 0 marks. So if you're not very well aware of the formulae, then there is no point of doing this. So the first set is 1 upon x square minus a square dx, which is 1 upon 2a log mod x minus a upon x plus a plus c. Okay, and then 1 upon a square minus x square, that is 1 upon 2a log mod a plus x upon a minus x plus c, right? This is the second category. The second category has root. Okay, so just take a look at the formula. 1 upon root of x square plus a square dx is equal to log modulus x plus root of x square plus a square plus c, and 1 upon root of x square minus a square dx is equal to x square minus a square dx is equal to log modulus x plus root of x square minus a square plus c. And the third category, the root of x square plus a square dx is equal to x by 2 root of x square plus a square by 2 log mod x plus root of x square plus a square plus c, and root of x square minus a square dx is equal to x by 2 root of x square minus a square by 2 log modulus x plus root of x square minus a square plus c. Okay, so we had written this earlier, but then once again I just have gone through this. Exercise 5.4, which is on page number 129, question number 1. Integration of 1 upon 4x square minus 1 dx. Keep yourself on mute. 1 upon 4x square minus 1 dx. Okay, now see, down there is a quadratic. Down there is a quadratic without a middle term. We don't have a middle term over here, right? And up there shouldn't be x. There should be some constant like 1, 2, 3, 4. Okay, so in this problem, what we'll have to do is we will first eliminate 4. Now this many students are not doing despite giving clear cut instructions. I've seen in the prelims as well. Eliminate this 4. Whatever is besides x square, just eliminate it. All these instructions are given to you beforehand, but then you don't do it. So 4 x square minus 1 upon 4 dx. Now please don't ask if we can't eliminate this. No, that's not an option. Don't keep it as it is. Okay, because it will help you in the next set of problems. Don't ask if we cannot eliminate this or not. Please don't do that. I've given the instruction besides x square, whatever term is there, just eliminate it. So 1 upon 4 integration of x square minus 1 upon 2 the whole square dx. Okay, 1 upon 4 being a constant, it came outside. Okay, and then we are left with x square minus 1 upon 4. So that we are writing it as x square, and 1 upon 4 being a perfect square, I'm writing it as 1 upon 2 the whole square, right? Okay, now which formula to apply? So this is x within the bracket and this is a, so it will be 1 upon x square minus a square, 1 upon x square minus a square. So always write down the formula first. After this step, please write down the formula. 1 by 4, put a bracket over here, 1 upon 2a log modulus x minus a upon x plus a plus c. What is a? A is half. Try and understand. A is half. See, so a is half log modulus x minus half upon x plus half plus c. Okay, this 2 and 2 will get cancelled. So this is 1 upon 4 log modulus 2x minus 1 upon 2x plus 1. I hope you understood how it is 2x minus 1 upon 2x plus 1. I'm taking the LCM over here. Okay, multiplication of 2 into x and multiplication of 2 into x. I took the LCM, and whatever 2 is left down, it is getting cancelled. Okay. Next problem. Exercise 5.4. Exercise 5.4. Question number 6. Integration 1 upon a square minus b square x square. A square minus b square x square. So this b square is besides x square. B square is besides x square. So our ground rule is whatever is there besides x square, just eliminate it. Whatever is there besides x square, please eliminate it. Okay, so b square has to get eliminated. So I'm taking b square common. Now a square does not have b square along with it. So we'll write this as a square upon b square. If the term is not there along with some term, divided. Okay. So this is 1 upon b square, integration of a upon b the whole square minus x square dx. So now this becomes a within the bracket, whatever is there, it becomes a, and this becomes b. Whatever is there within the bracket becomes a. First bracket becomes a, second bracket is, sorry, not b, but then x. Okay. So this is equal to 1 upon b square, right? Let's write down the formula. So it is 1 upon a square minus x square. I'll show you the formula. It's the second formula over here, 1 upon a square minus x square. I'll write down the formula. 1 upon 2a log modulus a plus x upon a minus x, right? Plus c. Now in this, what we are supposed to do? In this, we are supposed to put the value of a. Replace a with a plus b and replace x with x. Okay. So the next step, 1 upon b square, 1 upon 2, a is replaced with a upon b, a upon b plus x, a upon b minus x. Okay. Now this b square and b will get cancelled because there is multiplication over here, right? So we are left with 1 upon 2 ab, 2a and b log modulus. Take LCM over here, a plus bx, a minus bx, right? So that's the final answer. So these problems I'm taking which are not having a middle term in between. Don't take -1 and all outside, please. Whatever instructions I'm giving, stick to that. Okay. Question number 8 from the same exercise. Root of 3x square plus 8 dx. Again, eliminate 3. 3 is besides x square, just eliminate it. First within the root. So this will be 8 upon 3. Right? Now since there is multiplication over here, we can separate these two terms. Okay, the constant 3 and the bracket can be separated because we are having multiplication. So 1 upon root 3 integration of x square minus 8 by 3. 8 by 3 is not a perfect square. 8 by 3 is not a perfect square. So let it be root 8 by root 3. I've written 8 by 3 as root 8 by root 3. Okay, now this time it is x within the bracket and a within the bracket. And now there is a root. There's a root. Don't forget to write this root. Otherwise, you will apply the wrong formula. 1 upon root of x square minus a square. So it will be from the second category. 1 upon root of x square minus a square. So first write down the formula. So after this step, I'm going to write down the formula. 1 by root 3. Okay. Log modulus x plus root of x square minus a square. 1 by root 3. Log modulus root of x will get replaced with x because in place of x, x is there. And a will get replaced with root 8 by root 3. Minus root 8 by root 3 the whole square plus c. Okay. Some simplifications. Okay. Root 8 by root 3 the whole square is 8 by 3. Now within the root we'll take LCM and wind up the problem. Within the root we'll take LCM and wind up the problem. Okay. So 3 into x square, 3x square minus 8 upon 3 plus c. Now if you find a different answer in the textbook, don't panic. This is also right. Let's proceed with the next problem. 10th problem from exercise 5.4. Okay, it's literally the same problem. Can you tell over the chat which term we are supposed to eliminate first? Root 3 is wrong. Root 3 we don't have to eliminate first. We have to eliminate 3. We have to eliminate 3. So that problem you can try on your own. I hope the entire methodology is clear now. Okay, go to miscellaneous exercise. Miscellaneous exercise. Question number 3. Sub question 1. It's on page 138. Keep yourself on mute, please. So the question is like this: 4x square minus 5. Integration of 1 upon root of 4x square minus 5. So first eliminate this 4. Right? So this will become 5 by 4. Now there is a multiplication over here. So these two terms, the green color term and red color term, will get separated because of the multiplication. So this can be written as 1 upon root 4 integration of x square minus 5 by 4 dx. Make use of brackets and all. It's very essential. Right? So 1 upon 4, I'll write it as 1 upon 2 integration. Okay. 1 upon 2, this I have written as 1 upon root 4 is written as 1 upon 2. This x square is written as x the whole square minus, can you suggest 5 by 4? What should I write within this bracket which I have left empty? Correct, root 5 by root 4. Root 5 by root 4, or rather we will write root 5 by 2 because 4 is a perfect square. So root 5 by 2. Okay. Somebody is not on mute. Please check. 1 upon 2. Formula number 2, right? Log mod x plus root of x square plus a square plus c, half log mod x square minus root 5 by 2 the whole square plus c. Okay. Yeah. Then root 5 by 2 the whole square. Okay. So root 5 by 2 the whole square can be written as 5 upon 4, and then you can take the LCM within the root. That's it. Okay. So this is equal to 1 upon 2 log mod x plus root of x square minus 5 upon 4. I hope you're understanding the steps. Now root 4 is 2. That's it. Next problem. Just a second. Yeah. So question number 3, sub question 3. You can practice this on your own. I'll just give you a guideline. Now this time there is no root. So unnecessarily don't apply root formula. First step is whatever is besides x square, just eliminate it. So this will be x square 9 into x square minus 25 by 9. So 1 upon 9 outside being a constant, and then 1 upon x square minus 5 by 3 the whole square. Then you have to apply formula number 1. Okay, where x is x, and a is 5 by 3, right? Question number 3, sub question 6. It's on page number 139. Question number 3, sub question 6, which is on page number 139. Integration of 1 upon 5 minus 16x square. Okay, whatever is besides x, eliminate that term. Okay, so 1 upon 16 outside, root 5 by 4 the whole square. You have to make this a perfect square, dx. So whatever I am marking, root 5 by 4, that becomes a, and x remains x. So 1 upon a square minus x square, which is the second formula. 1 upon a square minus x square. So 1 upon 16 will remain as it is. Always write down the formula once again. 1 upon 2a log mod a plus x upon a minus x. Put a curly bracket. 1 upon 16 a. What's a? A is root 5 by 4. Log modulus a is root 5 by 4 plus x root 5 by 4 minus x. Okay, so 2 ones are 2 twos are, and 2 ones are 2 eights are. So 1 upon 8 root 5 log modulus LCM, correct, root 5 plus 4x upon root 5 minus 4x. Okay, right? One extra problem. Root of x square minus 7 dx. Now this time this term is there in the numerator. So this can be written as root of x square minus, fill in the blank, come on. What can we write within the bracket? Root 7. So this is x and this is a. So this is a third category formula. Third category formula. So x by 2 root of x square minus a square minus a square by 2 log mod x plus root of x square minus a square plus c. So x by 2 x square minus root 7 the whole square minus root 7 the whole square by 2 log mod x plus x square minus root 7 the whole square plus c. So root 7 the whole square can be written as 7. Wherever I'm marking in red, all those terms can be written as 7. That will be the end of the problem. Okay, now some people have the habit of writing root like this. For example, this root they will write like this. You have to write very precisely. You cannot just irritate the paper corrector. Write it very precisely. So the first category of this kind of problems are over. First category. Do you agree with me? The first category is over. Now we are going to the second category. Now in the second category, we will be having a middle term. In the second category, we will be having a middle term, right? So let's go back to exercise 5.4, question number 2. It's on page number 129. 5.4, page number 129. Question number 2. Integration 1 upon x square plus 4x minus 5 dx. Now, first of all, there shouldn't be any x term in the numerator. Is there any x term in the numerator? By the way, dx is not an x term, please. There is no x term in the numerator. Okay. Now we have a middle term. Okay. Is there coefficient of x square anywhere? Is there anything besides x square anywhere? Besides x square, nothing is there. Okay. So our first point of check is to eliminate something which is there besides x square. So if that thing is not there, it's okay. Then proceed. How to proceed? Half into coefficient of xd whole square. So half into 4 square, which is equal to 2 square. Half into 4 square, which is equal to 2 square. So this is integration of 1 upon x square plus 4x plus 2 square minus 5 minus 2 square. Now there is a particular thing in which I have asked you to do this. So this 2 square has to be placed before the constant. Constant is minus 5 over here, and after the constant. Before the constant, after the constant. Now before the constant it is plus 2 square, after the constant it is minus 2 square. Don't interchange the sign and don't even ask why. Before the constant and after the constant. Do you recollect this? Okay. After this, first 3 terms and the last 2 terms. First 3 terms and the last 2 terms. So it will be x plus to the whole square. X plus to the whole square. Combination of the first 3 terms. Integration of x plus to the whole square. Okay. Now always solve the last 2 terms in rough work. Please solve this. Don't be under any, overconfidence. So minus 4, minus 5, minus 4, which is minus 9. So first we are going to write minus 9. We are going to write the board exam only once. So you are entitled to write each and every step. If you want to skip any steps, that is definitely up to you. Then you are responsible for your marks. X plus to the whole square minus 3 square. 9 is written as 3 square. So this is x and this is a. X and a. Guys, what is x? Can you tell me? X is x plus 2. My next question, is x plus 2 linear algebraic? Yes, x plus 2 term is linear algebraic. Okay, so apply the formula. Which formula to apply? We can apply the first formula from the first set. We can apply first formula from the first set. Okay, so just write down the formula. 1 upon 2a log modulus x minus a upon x plus a. X minus a upon x plus a. What is a? A is 3. Log modulus x minus 3 upon x plus 3. So this is 1 upon 6 log modulus x minus 3 upon, oh sorry, I didn't substitute the value of x, sorry. In place of x we are having x plus 3, right? X plus 2, and in place of a we are having 3. So x plus 2 in place of x minus 3 plus 3. Okay, right? Now in this type of problems, if you miss out on dy dx of x plus 2, it's okay, because x is getting replaced with x plus 2, right? So even if you miss out on that upon dy dx of x plus 2, ideally you should write, but then even if you miss out, it's fine, because that has been taken care of only in this type of problems. X minus 1 x plus 5 plus c, and those who want to write that step, those people can write dy dx beneath this, dy dx of x plus 2, which is 1. Okay, that's the final answer. Just share your feedback whether you have understood this problem or not. Okay, now next problem, third problem. Integration of 1 upon 4x square minus 20x plus 17. Should I go ahead with half into coefficient of x? There is a constant in the numerator, that's fine, and there is a middle term. So should I go ahead with half into coefficient of x? No. Keep your basics in place. If I've advised you to do something, you are supposed to do that thing. Don't deviate from my instructions. So first eliminate 4, and that too very clearly. So I'm taking 4 common because 4 is besides x square, right? So 1 upon 4 outside, 1 upon x square minus 5x plus 17 by 4. I hope you understood how I've written this 20 as 5, because 20 has 4 inside it, but then 17 does not have 4. Okay, all these problems were done earlier in class. Okay, now we can go ahead with half into coefficient of x. Write down that step for the paper corrector. Half into coefficient of x the whole square. Half into, what's the coefficient of x? Coefficient of x is minus 5, but then I'll write 5 because we have a square. Even if you write minus 5, it's okay, but then minus will get eliminated due to the square. So 5 by 2 the whole square, we'll have to place it somewhere. Where we can place 5 by 2 the whole square? Before the constant, outside the, after the constant. What is the constant over here? 17 by 4. So before 17 by 4, after 17 by 4. What we have to place before 17 by 4? Plus 5 by 4 the whole square. So this is equal to 1 by 4 integration of x square minus 5x plus 5 by 2 the whole square, okay, plus 17 by 4 minus 5 by 2 the whole square dx. Many people have a very bad habit of not writing dx. I don't know why. Those who are very over smart will do that. Why dx is important? Dx is very important in the problem of method of substitution. Otherwise, you'll keep searching where is dx if you don't write it. So always write in a very precise way. First three terms and the last two terms. First three terms and the last two terms. X, this time minus 5 by 2 the whole square. X minus 5 by 2 the whole square. Okay, always solve the last two terms. Always solve. So plus 17 by 4 minus 25 by 4. What is plus 17 by 4 minus 25 by 4? Is it minus 8 by 4? And what is minus 8 by 4? Minus 8 by 4 has to be written as minus 2. Minus 8 by 4 can be written as minus 2. Okay. So integration 1 by 4 x minus 5 by 2 the whole square. Okay. And this 2 can be written as root 2 the whole square. So this is x, what is there within the bracket, and this is a. By the way, a is not root 2 the whole square. Please remember this. A is only root 2. So 1 by 4, let's apply the formula 1 upon x square minus a square. Okay, again the first formula 1 upon 2a log modulus x minus a upon x plus a. X minus a upon x plus a. Now replace x with x minus 5 by 2, and remember x minus 5 by 2 is a linear algebraic term. A is root 2, so x minus 5 by 2 plus root 2 x minus 5 by 2, so it is minus on the top and plus down. Okay, now down there is d by dx of x minus 5 by 2, which has to be 1. And why it is 1? Because we have already eliminated this 4 over here. Okay, so upon d by dx of x minus 5 by 2, which is 1, and within the modulus, take LCM. So can you tell me the exact value of the entire modulus, numerator and denominator, after taking LCM? Come on, tell me. Correct. The numerator is 2x minus 5 minus 2 root 2, and the denominator will be 2x minus 5 plus 2 root 2. 2 will go and get cancelled. Okay, fine. Let us go ahead with the next example. Example number 11. Example 11. integration of 1 upon root of x square minus 8x minus 20 dx, x square minus 8x minus 20 dx. So now this time it's a root down in the denominator. There is no x term in the numerator, and we have a middle term, that is minus 8x. Okay. First and foremost, is there any coefficient of x square? No. So if there is no coefficient of x square, no point of eliminating anything. So half into coefficient of xd whole square. So half into 8d whole square, coefficient of x is minus 8, but then minus, even if we put square, will eliminate the minus sign. So this is 4 square. Now don't write 4 square as 16. Before the constant, after the constant, we are going to place this 4 square. So x square minus 8x plus 4 square minus 20 minus 4 square. Before the constant plus 4 square, after the constant minus 4 square. First 3 terms and last 2 terms. And while writing the next step, do not forget to write the root. The root should be entire. Many students write this step very clearly, and in the next step they forget writing the root and they apply the wrong formula. This is nothing but pure ignorance. Yeah. So can you tell me what is the combined term for the first 3 terms? Waiting for your answer. Waiting for your answers. Only few people are replying. Combination of the first 3 terms. X minus 4 the whole square. X minus 4 the whole square. Combination of the last 2 terms. It is minus 36. It is pretty clear. Okay. I've seen students doing this as well. Square root and square gets eliminated. 36 root is 6. Is this correct? Absolutely not. Because there is minus sign in between. Now 36 has to be written as 6 square. Okay. So this is x and this is a. Second category formula. The second one. 1 upon root of x square minus a square. Okay. So first write down the formula. Log modulus x plus root of x square minus a square plus c. Now in place of x, we are having x minus 4, which is a linear algebraic term, plus x minus 4 the whole square minus a square is 6. So minus 6 square. Now moreover what you can do is you can just simplify this within the root. You have to simplify this within the root. I have given my instruction. Right? Okay. One more problem from the same exercise, which is really very important. Okay. So I'll take you to that problem. Go to page number 129. Question number 7. Mark it very important for the boards. Yeah. So question number 7, I'll start with that right now. Page number 129. Integration 7 plus 6x minus x square dx. Rearrange. So minus x square plus 6x plus 7. Take minus sign common. Okay. Now a very important instruction I'm giving you. You can take this minus sign outside and solve the entire problem as it is. But I am strictly not recommending that. It will be definitely right, but then I don't recommend it. And all the instructions I give over the years is after speaking to certain moderators as well. So don't take that minus sign outside. Is this clear? Okay. Now go ahead with half into coefficient of x within the bracket, within the round bracket. So what is the coefficient of x? Coefficient of x is minus 6. We'll take 6 half into coefficient of x the whole square, half into 6 the whole square, 3 square. Minus sign before the constant, after the constant is minus 7. X square minus 6x plus 3 square minus 7 minus 3 square. First three terms. Can someone tell me what is the answer for the first three terms? Wrong. It is x minus 3 the whole square. It cannot be x plus 3. It is x minus 3. This sign is important. Last two terms is minus 16 because minus 7 minus 9 is minus 16. Now minus 16 minus, keep it aside. 16 can be written as 4 square. Sixteen is written as 4 square. Okay. Now minus of a minus b is equal to b minus a in entire mathematics. So take this minus sign inside the box bracket. The terms will reverse. So this is A and this is X. A and X. Okay. So 1 upon A square minus X square formula. I'll show you the formula. 1 upon A square minus X square formula. See, application of the right formula is very critical. 1 upon 2A log modulus A plus X upon A minus X. What is A? A is 4. Log modulus 4 plus and 4 minus. And what is X? X is X minus 3. Okay. Upon dy dx of X minus 3, which is 1. Chain rule. Okay. So 1 upon 8 log modulus 4 minus 3 is 1. 1 plus X and 4 plus 3 is 7 minus X. This is your final answer. Okay. There are some problems like this in the miscellaneous which you can solve it for yourself, right? Go to miscellaneous exercise, page number 138. Question number 3, sub question 3. Question number 4, sub question 6 and 7. You can practice. Question number 3, sub question 3 is same just what we have solved right now. And question number 4, sub question 6 and 7, it's half into coefficient of X, but this time we'll be using the third category of formula. It will be either this or this. Okay. Is that very clear? Yeah. Now the third category of this problems. Third category of this problems. Okay. Go to page number 129. It will involve method of substitution. It will involve method of substitution. So I'll not be solving this problem entirely, but then we'll understand how method of substitution works in these problems. The first part will be method of substitution in this such kind of problems. Exercise 5.4, question number 4. Integration x 4x raised to 4 minus 20x square minus 3 dx. Okay, just observe. Is there any x term in the numerator? Yes, there is an x term in the numerator. Now what we are going to do is, we cannot apply half into coefficient of x. Obviously, there is no quadratic down. So we have to make certain adjustments. The first adjustment, x raised to 4 can be written as x raised to 4 can be written as x square the whole square. And let this be equation number 1 now. Let this be equation number 1. Put x square equal to t dy dx of x square dy dx of t. What is dy dx of x square? 2x dt by dx. Right? Yes or no? Now look at equation number 1 and tell me what terms we have to club together. These are 4-mark problems which I am discussing with you right now. So in equation number 1, look at x dx. So these are the terms which you are supposed to group. Therefore, x dx is equal to dt by 2. Okay, so from 1, at the same time, what you're going to write x square as? You're going to write x square as t. So from 1, x dx becomes dt by 2. Write it towards the very end. I've written x dx as dt by 2 towards the very end. 1 upon 4t square minus 20t minus 3. Okay, just take this to outside. Now how to solve this further? How to solve this further? Waiting for your comments. First eliminate 4 because it is besides t square. After elimination of 4, after elimination of 4, what we are going to do? We are going to apply half into coefficient of t the whole square. It won't be half into coefficient of x. Concept remains same, correct? But then half into coefficient of t the whole square. Okay, and at the same time you can now multiply this 4 and 2 and write 1 upon 8 outside. Solve the entire problem in terms of t. Solve the entire problem in terms of t, and then towards the very end replace t with x square. Replace t with x square. Do you want me to solve this further? Or should I go to the next problem? Please revert. Don't keep me waiting. You want me to solve this further, or should I go to the next problem? Okay, next one. Question number 5 from the same exercise. Integration of x cube 16x raised to 8 minus 25 dx. Now, first of all, there is no quadratic down, but then x raised to 8 can be written as x raised to 4 the whole square into 20 minus 25. Equation number 1. Now, can you suggest what should I do? I've given you one hint. Can you suggest? I'm not getting answers from many people over here. Only one or two students are replying. Put x raised to 4 is equal to t. So d by dx of x raised to 4. Everything should be very clearly written. Don't make the life of the paper corrector difficult. Otherwise, he will not consider giving you marks. So 4x cube is equal to dt by dx. Now, after this step, always look at equation number 1. X cube dx and x cube dx. So just club it. X cube dx is equal to dt by 4. From 1, x cube dx is equal to dt by 4. 1 upon x raised to 4 is t. So 16 t square minus 25. So 1 upon 4 outside, 16 t square minus 25 dt. There is no middle term. Eliminate 16 over here. 16 fours are 64, which can be written in the denominator. And this can be written as integration of t square minus 5 by 4 the whole square. Write the formula in terms of t, solve it, and towards the very end, replace t with replace t with replace t with x raised to 4. Okay. I hope you understood this. Right? Next problem. Go to the miscellaneous exercise. Page number 139. On the top, there is question number 4. Integration of e raised to x root of e raised to 2x plus 4 e raised to x plus 13 dx. So e raised to x, okay, you can write e raised to 2x as e raised to x the whole square, right, plus 13. Okay, anyone can suggest me what should be the next step, because I'm not going to solve this entirely. This is equation number 1. So put e raised to x is equal to t. So what will be the value of this yellow colored e raised to x dx? Come on, tell me. Dt, correct. Okay, so there is one more problem of this category. The rest of the solution you can go through my notes. I have solved this very precisely in my notes. Even if you take a look at this problem, now you can understand. And towards the very end, replace t with x square. T with, sorry, not x square, e raised to x. Page 139, question number 8 on the top. E raised to x, 4 e raised to 2x minus 1. 4 e raised to 2x minus 1. So this is e raised to x, 4 e raised to x the whole square dx. Correct? E raised to 2x, what I have written as e raised to 2x as e raised to x the whole square. So put e raised to x as t. Put e raised to x as t. Right? The top e raised to x dx will become what? I'll solve it so that those who are still confused, they will get some help out of it. Put e raised to x is equal to t, d by dx of e raised to x, d by dx of t, e raised to x is equal to dt by dx, e raised to x dx is equal to dt. Why I'm grouping e raised to x dx? Because it's there in the numerator of the problem. See, e raised to x dx. So from 1, e raised to x dx will become dt, and this is 1 upon 4t square minus 1. 4t square minus 1. Right? So you can eliminate. How to solve this further? 4t square minus 1. Come on, tell me, guys. Hello? Wrong. It cannot be 2t square. I have already told, don't do this method, 2t square. How it can be 4t square minus 1 with log? You're putting entire effort into down the drain. Some people are telling log and some people are clubbing this and writing as 2t square. Already the instructions are given to you. Then to why you people are wrong? Eliminate 4. Then what's the use of revision? And I'm making you do this because I have bigger problems in my mind as my vision. So this is x as in this is t, and this is a, 1 upon t square minus a square, 1 upon t square minus a square. So the formula remains the same, 1 upon x square minus a square. X and t are one and the same almost. So 1 upon 4, 1 upon 2a log mod t minus a upon t plus c, 1 upon 4 2a. What is a? A is half. Log mod t minus half t t plus half plus c. 2 getting cancelled. 1 upon 4 log mod 2t minus 1 2t plus 1. And towards the end, replace t with e raised to x. That's it. Procedure should remain the same. Next problem. Next problem. It's on page number 139. Question number 5. Integration of, see how they have given, dx x log x the whole square plus 4 log x minus 1 bracket close. So we are going to rearrange the terms. This x, I'll write it as 1 upon x towards the end, and the box bracket first I'm going to write log x the whole square 4 log x minus 1 into 1 upon x dx. I'll just give you the hint. Put anyone? Put log x equal to t. So 1 upon x dx will be dt once you solve. 4-mark problem. Very simple, very scoring. Okay. Any further problem in this? Okay. Last problem for the day. And then I will share with you a rough plan of how I'm going to revise further. Page number 139. 3 sub question 8. 3 sub question 7. Integration. dx upon 25x minus x log x the whole square. So take x common and put it towards the end because there is a log term. So 25 minus log x the whole square, right? 25 minus log x the whole square, and this x I've taken out as 1 upon x as a common term. Now you can put log x is equal to t. Now you can put log x is equal to t. Okay, that's it.